We have seen that two exterior angles and one interior angle, they are concurrent at I1, perpendicular from I1 on to BC. D. Yes. कोणाला माहिती कसं काढायचं कारण माझी पेन सगळी त्याच्या मागे गेली. Yes. Thank you. E1 F1 and because I1 D1 I1 E1 I1 F1 are equal, we can have a circle, yeah, touching these points, and it is also touching all three sides of triangle. This is outside a triangle ABC, so we call it as a circle. We call this center as X center, and all these three are X radii. Okay. That was the part which we have discussed last lecture. Add a minute. Any doubt, difficulty? Because I think we did this at the end. कोणाला काही शंका असतील तर विचारा. इतर नोट्स मध्ये पण बोलते आहे. So sir, X center I1 finally A1 I1 वर in center मध्ये in center पण याचं काही आहे direction. This is I, where internal angle bisectors are concurrent and there is a in circle. Yeah, so all these four circles are going to be interconnected. That is what we will do today. They are connected to each other, related. So whatever work we have done opposite to capital A, internal angle bisector of capital A and external bisector of B and C got one more concurrency and hence one more set of circles. So if it is true opposite A, it should be true opposite to B and it should be true opposite to C also. So there should be three X circles. So this is X circle opposite to A. Next will be X circle opposite to B and the third one will be opposite to C. It is extremely difficult to draw that diagram, but we will try because we have got so many properties in that particular figure. So let us leave this. Okay, so I have got all the angle bisectors, internal, external. So this is I1, this is called I2, this is I3. Notation. Put a perpendicular from I on BC. The put of perpendicular is B. From I on AC is E. And from I on AB is F. From I1 from I1 on BC is D1. I1 AC E1 and I1 F1. From I3 to E2. D2. F2. Then I3 F3 D3 E. So this is simple. Whatever is the put of perpendicular on line BC is D and corresponding from where it is put corresponding suffix. I2. Okay. Now let me just put circles also. The circles. So this is standard notation. All the names of those points are also standard. Now, interesting part is this is internal angle bisector. These two angles are equal. These two angles are equal, and these two angles are equal. Internal angle bisector. And this is external angle bisector. This is external angle bisector, and so on. All of them similar. Therefore, these two are vertex opposite angles. Here at C, AC and BC, they create angles like this. Suppose this is internal angles, this is external. And then we are drawing angle bisector of one of the external here. CI1 is external angle bisector and CI2 is external angle bisector of vertex opposite angle. Therefore, they are collinear. External angle of this side, external angle bisector of this side. That means they are opposite rays. This angle is equal to, suppose this is the A plus O plus X this side, A plus O plus X that side. Therefore, it is straight line. So we have drawn separately exterior angles, but it is one line. I2, C and I1 are collinear. I3B and I1 are collinear. I3A, I2 are collinear. So it is not hexagon AI3, BI1, CI2. It is not hexagon. It is triangle I1, I2, I3. Triangle I1, I2, I3. Okay, that is why we did that theorem, vertex opposite angles are equal, etc. Moreover, if you look at the internal angle sector, now if you consider this as a linear pair, ACE1 as a linear pair, and one angle is ACB and another is BCE1. Do you see that? There is a linear pair ACB, ACB and BCE1. Correct? They form a linear pair ACE1 plus I angle. So ACB and BCE1 add up to 180. And now we are talking about their corresponding angle bisectors. Angle bisector of this internal and this is external, and we have said that they are supposed to be perpendicular. X, Y, Y, therefore x plus y is 90. Therefore, this internal angle bisector perpendicular to I1, I2. Similarly, AI1 is perpendicular to I2, I3, and BI2 is perpendicular to I1. This is additional. So, angle bisectors from A to I1 look like an altitude from I1 to A. Altitude is perpendicular from the vertex on opposite side. It is called altitude. So, if we look at it from A to I1, it is angle bisector of BAC. But if we look at it from I1 to A, we have dropped perpendicular. It is put up perpendicular from I1 on I2, I3. That is why this particular configuration is very, very interesting. This is
Sorry, sir. I could not understand the perpendicular part. Can you please repeat that?
yes. Do you remember having done this? Do you remember having done this? If we have a linear pair and if we have two bisectors of angles linear pair,
Then they are 90 degree. Yeah.
then they are perpendicular. We have done it on, I think, first page. So here exactly similar situation. ACB is one angle and BCE1 is another angle. They form linear pair and their corresponding angle bisectors CI3, CI1. Therefore, angle between CI3 and CI1 is 90 degrees. Therefore, I1C is perpendicular to I1I. I3C is perpendicular to I1I2. This diagram is in center, X center, perpendicular. So I is in center of triangle ABC and I is orthocenter of triangle I1, I2, I3. When three altitudes meet each other, they meet at one common point. Like in triangle, we have seen perpendicular bisectors are concurrent. Then we have proved angle bisectors are concurrent. We will prove later. Medians are concurrent. and altitudes are concurrent. Out of which angle bisectors are concurrent. We are developing the theory based on this. We have put one internal angle bisector. Suddenly we realize that there are two external and one internal are also concurrent. And if one is there, then all three will be there, and hence we got this configuration. So it is exploiting angle bisector concurrency in this figure. However, because of perpendicularity that we have achieved, we have got this concurrency, altitude concurrency. Only thing is that altitude concurrency is for triangle I1, I2, I3. And angle bisector concurrency in this diagram is for ABC. So only we have to prove otherwise also that altitudes are concurrent. But you can consider this as one of the proofs because angle bisectors are concurrent, altitudes are concurrent. Okay, इथपर्यंत चांगलं झालंय. Okay. Now let us keep this to the side and work on the distances. I will bring this after some time again because it is reasonably very good diagram right now. Very difficult to make. Suppose we have a triangle, and I think we have proved delta is equal to RS. Delta is equal to RS. It was related to in center, and we draw three triangles ABC, AIB, BIC, and CIA. And because the height is same, we got very good formula for area, which is delta is equal to RS. All the heights are. But if something is possible to find out using in center, then something similar should be there for X center. So let us work on this. Let us look at this diagram and try to, because in center formula in center there is nothing so special. Similarly, exact weightage for I1 also. So we should get one more formula for I1. Okay, let us see. So what did we do here? We joined I with vertex BC and A. So let us join I1 with vertex BC and A, which is already there in this diagram. We have joined I1 with B, C, and A. So let me just write down the way we did it here. Area of ABI plus area of BCI plus area of CAI. That is what we calculated, and the height was same. Therefore, we could get delta is equal to RS. The approach is same, only instead of I, we are putting I1. So we wish to find area of triangle, and exactly similarly, we would like to put ABI1, area of ABI1 we want to measure, then area of ACI1, CAI1 we want to measure, and then area of BCI1 we want to measure. Okay, and eventually after we measure these three areas, like here, we added, maybe we will have to do something else because our I1 is not inside the triangle, I1 is outside it. So let us look at it. Here is complicated, but we can look at it in isolated way. Can we see triangle ABI? Okay, let us make this figure T. This is ABI. This is right. Can we figure out triangle CAI1? Yes. This is triangle CAI1. Good. And then can we find out angle BCI1? Yes. Okay. What algebra should we do with these three triangles? Orange, green, and blue, so that we get area of triangle ABC. Therefore, I have not put signs here. Correct? Easy? Plus, minus. We have to add two big triangles and subtract the smaller one. Then we will have area of triangle ABC. बरं चाललंय? ठीक. Okay, now it is going to be challenging to find out the actual areas. We can choose any of the three sides as base and corresponding height. So what should be the base for ABI1? We want to find out area of ABI1. What should be the base? Yeah, then we'll have to put perpendicular from B onto AI, which is not available.
AI1.
AI1 is not good choice. BI1 is also bad choice because we have to drop perpendicular from A onto BI1, not available. But if we choose AB as a base, then the perpendicular is already available. So okay, AB into I1 F1 upon 2 is the area of ABI1. Similarly, CA into I1 E1 upon 2 minus BC into I1 D1 upon 2. Now, few of you will not understand this step. That is fine. We will explain it. Okay. So let us put some small letters. AB is small c. I1 F1 is R1 upon 2. CA is small b. I1 E1 is R1 upon 2 minus BC is small a into R1 upon 2. This is what is the area of triangle ABC. If we take R1 common out, then we have B plus C minus A upon 2. And we said that this quantity is R1 into S minus A. If you are using center opposite to capital A, then your area of triangle is R1 into S minus A, which was R into S. So there is symmetry, there is difference. Instead of R, we have R1 now, which is quite logical because R1 is X radius opposite to A. And instead of S, we have S minus A, which is also good because we are working opposite to A. So symmetry is there. And if this is true, then delta also will be equal to, if we do our work on vertex B, then our area will be S minus B. And if we do the same work opposite to C, our area will be R3 into S minus C. I will wait for some time. If you have any doubts, you can ask. That delta is area of triangle ABC. Any questions?
A plus B plus C by 2.
So,
How can it become S minus B?
S is equal to A plus B plus C upon 2. So let us see. Suppose we B plus C plus A upon 2 is S. Whatever. So suppose we write it B plus C plus आपल्याला पाहिजे B plus C minus A. We don't know what it is. This is different. You want B plus C minus A upon 2. Right? So what we do is B plus C plus A minus 2A upon 2. Which is B plus C plus A upon 2 minus 2A upon 2. B plus C plus A by 2 is S. Into A upon 2 is A. So whatever minus sign you have, it is S minus A. If A is negative in the bracket, then it is S minus. If B is negative in the bracket, it is S minus B or S minus C.
Sir, Rudresh here. Using this and Heron's formula, then we can also calculate R1, R2, R3 in terms of ABC, right?
Yes.
So these R1, R2 and R3 are basically the external radius, right?
Yes.
So it is capital R,
X radius.
X radius, yes,
Capital
So-
R is circumradius.
right.
So let us figure out how many area formulae do we have. Delta. We have fluid, R base into height. We have fluid. Delta is equal to root of S into S minus A into S minus B into S minus C. Heron's formula. Then we have fluid RS. Then we have fluid R1 into S minus A. Then we have fluid R2 into S minus B. Then we have fluid R3 into S minus C. And hence you can prove that delta is also equal to root of R1 R2 R3. Right? If you multiply all these four angles, four formulae, R into S, R1 into S minus A, R2 into S minus B, R3 into S minus C, all of them are multiplied. Everybody is delta. So delta raised to 4 will be R1, R2, R3 times S minus A, S minus B, S minus C. S minus B, A, S minus B, S minus C is delta square. So delta fourth is equal to delta square times R1, R2, R3. Therefore, delta is equal to square root of R1, R2, R3.
Sir, previously आपण ते delta is equal to area of AB I1 किंवा CA I1 वगैरे जे घेतलं ना तर तो I1 का घेतला मला एकदा परत एक्सप्लेन कराल का?
When we proved delta is equal to RS, we have got I in the picture. We give enough weightage to R. Joined IOA, IB and IC got three triangles and their total area is equal to area of ABC. That was the motivation. We did it in center and it worked very well. Summation of three areas and we got one more formula for area of triangle. Delta is equal to R. But then after that we found out a new concurrency, two external angle bisectors and one internal angle bisector. Then we said, okay, the way there is in center, there is X center. The way there is in circle, there is X circle. The way there is in radius, there is X radius. So if something is happening with I in center, something similar must happen with I1, X center. So we started thinking, can we find out area of triangle ABC? Then the procedure there was to join the base, join the sides with I. So we joined all the three sides with I1, first side, second side, and third. Okay, but then if we add all those three areas, then it is not equal to ABC because it is huge quantity. It is not equal to ABC, much bigger than ABC. So we thought what should be the algebra of these three areas. Then we realized that ABI1 and CAI1 is this quadrilateral. ABI1C, area of ABI1C is this much. But we wanted area of ABC. Therefore, we subtracted area of triangle BCI1. At the moment that algebra took place, we have got everything available with us. Again, I1 F1, I1 E1, I1 D1, they are equal. So we can take out R1 common. What remains inside bracket is S minus C. So it was very obvious step.
Thank you, sir.
सर मला शेवटची जी स्टेप आहे ना
हा.
एरिया इज इक्वल्स टू √R × R1 R2 R3 ते नाही समजलं सर.
हा, सांगतो. शेवटच्या स्टेप पर्यंत नाही. इथपर्यंत समजलंय? इथपर्यंत?
हो तिथपर्यंत कळालंय.
हा, मग हे चौघ जण आहेत त्यांच्याकडे लक्ष द्यायला.
ओके.
डेल्टा इंटू डेल्टा इंटू डेल्टा इंटू डेल्टा इक्वल टू डेल्टा रेज टू 4
हा
is equal to R into R1 into R2 into R3.
हा
S minus A,
हम्म.
S minus B, S minus. बरोबर?
हम्म.
We understand this formula, delta is equal to root of S minus A, S minus B, S minus.
येस. हा
Delta square is equal to this.
हा
So
ओके.
this is equal to delta square times R1, R2, R3.
ओके कळालं सर.
Delta square from this side gets cancelled with delta square from this side. Therefore, delta raised to 2 is equal to R1, R2, R3.
ओके समजलं सर. थँक्यू.
Therefore, delta is this.
बेसिकली ABC दिल्यावर आपण R1 R2 R3 कॅल्क्युलेट करायचं.
काढू शकतो. किंवा आता एवढ्या क्वांटिटीज आपल्याकडे आहे, त्यातल्या जर करेक्ट 3 दिल्या तर एबीसी पण काढू शकतो. इक्विलॅटरल ट्रायंगलला R1 R2 R3 इक्वल. आयसोसेलेसला त्यातले दोघं इक्वल असतात, एक वेगळा असतो. हा समजलं इथपर्यंत? ओके. So area business is over. We will solve some numericals where we will get practice of using this, and so that you will remember that. आपल्याला अजून काय करूया? अजून आपला डिस्टन्सेस. In center, ID, IE, IF, I, A, B, C, I is infinite. Okay. Suppose I have a circle and I have a point outside circle. Then we can draw tangent to this circle. Now we'll have to define what do we mean by tangent. Okay. Suppose I have a line and I have a circle. If I have a line and I have a circle, then there are three possibilities in the plane. Suppose this point is fixed and I want my line to pass through that point. And there is a circle. आता लक्ष द्या जरा, थोडं अवघड. So this is dynamic line, rotating line. This line will rotate like this. So three cases. One, this line will intersect the circle into distinct points. We call it as secant. Line which intersects circle into distinct point is called secant. A line which will not even be in contact with the circle, that is second position, second case. There is no name for because there is no connection. And the third thing situation is like you have only one point in contact. Now here there are 2 points in contact. Suppose I rotate this line little here. Then what happened is this point shifted here and this point shifted here. Suppose we call this as A1, B1. Then the new position after rotating it through some angle, we got new position A2, B2. If we further rotate A3, B2. Now you can see the distance, I mean circumferential distance between A2 and B2 is reducing. A3, B3 is still smaller. If we further take it near, again there are 2 points, A4, A5. And there will be one angle where you will get A, B coincident. They will be on one on the other. That position of secant, which is limiting position of secant, is a tangent. And then after that, if you further rotate, then it is going to be next situation, not intersecting. Okay, correct. Good. So this is called tangent. So what do we say? What do we mean by tangent? A line and a circle. A line and a circle. They have only one point in common. It is actually double root. There are 2 points always. When circle and straight line intersect, there will be 2 points. But in case of tangent, those 2 points will be one above the other. It is one and only same point coincident with the other. Okay, so we can define tangent like this, and then there is a property, and there is a property that we have to do that property also. There is a circle, and there is a tangent. Then that tangent is
perpendicular
to the radius segment at that point. She property. I think we will not get into the proof. Or is it doable right now? Easily understood or not? Line is given to be tangent. And suppose radius segment. Suppose radius segment is not perpendicular. To that particular line. I mean, not particular type of proofs we have not done. So at the moment, let us assume that if you draw tangent to the circle, the radius segment is perpendicular to that point. At that point, it is perpendicular and converse, both true. Okay, no proof right now. We'll discuss it later. So if I am drawing a tangent from outside, so this is given to you now that this is 90 degrees and this is radius. So if this is the point P and this is circle S, how many tangents are possible? How many such lines we can draw?
2.
One above, up and one like this. Yes or no? And again the same property will be available here. Let us call this point A, this point B, this point M. Correct? So if I want to prove PA is equal to PB, will you be able to tell me the test of congruency? I want to show to prove that. PA is equal to PB. It is given that from P you are drawing
ASS.
perpendicular. You are drawing
ASS.
It is given that
AHS.
RHS.
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 it is given that you are drawing tangent to the circle from the point outside circle. We have to show that this is called length of tangent. Now tangent is actually the line, but when we say length of tangent, it is the length of segment between point and point of contact. Length of tangent. Okay. So length of tangent, both sides is going to be same. I mean, because of symmetry. But if you really want the congruency test, then this side is common, which is hypotenuse. Both of them are radius segments, therefore they are common, they are equal, and both of them are perpendicular, therefore yes, by RHS. The length of tangent, both sides is going to be equal, always. चालू केल्यावर बंद पण करा. हा, समजलं का इथपर्यंत? Okay, length of tangent. So coming back to this figure, we have got in circle. Correct? So in circle is a circle and A is a point outside circle. Therefore, which two segments are equal? AF and AE. B is also out of circle. So BF is equal to B. And CD is equal to CE. Lengths of tangent. Just now we have done that work. Lengths of tangents are supposed to be equal. Okay. Suppose we call this AF as X and AE as X, BF as Y, BD as Y, C as Z and CD as Z. Then perimeter P of triangle ABC, perimeter is equal to P is equal to AB plus BC plus C. Correct? But AB is X plus Y. BC is Y plus Z. And CA is Z plus X. Therefore, we get 2 times X plus Y plus Z is perimeter. We don't use perimeter anywhere in our calculations, but we did use semi-perimeter. So perimeter is 2 times semi-perimeter. Therefore, semi-perimeter is equal to X plus Y plus Z. Therefore, X plus Y is equal to S minus Z. X plus Y is equal to S. Or Z is equal to S minus X plus Y.
सर स्क्रीन थोडी वरती स्क्रोल कराल का? खालचं दिसत नाहीये.
स्क्रीन शेअर आहे ना?
आहे, खालच्या लाईन्स आत्ता दिसत नव्हत्या, आता दिसल्या.
ठीक आहे.
हा.
So
ओके,
Z
थँक्यू
is
सर.
equal to S minus X plus Y. But in the diagram, X plus Y is small c. So Z is small c. Similarly, Y is S minus B. And X is S minus B. So the identities which are there in Heron's formulae are present geometrically in circle configuration. So foot of perpendicular will not go anywhere, but from I on AB, if you are putting it will be at S minus A distance from A and S minus B distance from B. That foot of perpendicular is fixed. There is a chance that few of you will not understand what has happened here, but you can take your time.
Sir, when you are finding that perimeter, why are you writing the 2s? I couldn't understand that part, sir.
Yeah.
2s.
2 times semi-perimeter is equal to perimeter.
Yes, sir. Okay, 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 sir.
Okay, very good. Any questions? Actually, areas are under function. S into X into Y to Z. X and Y के temporary delay. Now, see, X is S minus S minus. No, this is S minus A. X are just understanding. X, Y, Z is not standard notation. Just to make it very clear, we are doing it. AF, AE, S minus A. BF, BD, S minus B. CD, CE, S minus C. Okay. So this is something which is not seen by students anytime. They just use Heron's formula several times, but they do not know where this S minus A is, where this S minus B is, S minus C is in this diagram. But then now we could get one formula delta is equal to RS because of in-center. And then we said if in-center can provide us one area formulae, then why not X-center? Therefore, we went behind X-centers and got 3 more formulae per area. Now, this analysis is available for in-center. Therefore, similar analysis should be available for X-center also. Something similar should be there for X-center also. Because, see, out of total 4 in Heron's formulae, S minus A, S minus B and S minus C, we could achieve only 3. So maybe if we continue our work on X center, we will get S also and remaining few more things. So let us do that. I1, B1, E1, F1, A, B, C. There exists a circle. Okay, we have a circle, we have I1 with us, and their points of contact. Sure. Let us begin. What did we do there first? First, we wrote the length of the tangent 310. So, consider X circle 1. Find A is outside. Therefore, AF1 is equal to AE1. Length of tangent. Consider X circle and B is also outside. Therefore, BF1 is equal to BD1. Consider X circle and C is also outside. Therefore, CD1 is equal to CE1. This is what we have achieved so far. And then what did we do in case of in center? Once we wrote these three, we said we'll write perimeter. Okay. We said we will write perimeter and then we try to break it in parts. Perimeter equal to AB plus BC plus C. Correct? Let me just put the small letters also. AB is small c, AC is small b, and BC is small a. BC is small. Now, I mean, this is little trick over here. This is equal to AB plus BD1 plus D1C plus C. I mean, you don't mind breaking BC in two parts. Stop at D1 and then go from D1 to C. D1 is inside. Correct. But we said BD1 is equal to BF1. This is equal to AB plus BF1. And D1C is equal to E1C. Okay. But if you look at the diagram, AB plus BF1 is AF1. And AC plus CE1 is AE1. But if you look here, both of them are equal. Therefore, this is equal to 2 times AF1, which is equal to 2 times AE1. But it was perimeter. Therefore, it is 2 times semi-perimeter. S is equal to AF1 is equal to AE1. So start from vertex and stop where you touch X circle. That distance is S. Okay, but then I am starting from here and stopping here, out of which if I remove C, then BF1 is S minus C. And BF1 is equal to BD1. If I look at the other side, I start from A, I stop at E1, it is S. AE1 is S. But if I remove B out of it, then CE1 is S minus B. And CE1 is equal to CD. Right? And if it happens opposite to A, it will happen opposite to B. It will happen opposite to C. Yes. If not clear, ask me.
सर ते S minus C is equal to नाही जरा लक्षात आलंय.
Now, A to F1 is S. हे समजलंय?
हा ते
Yes.
समजलं सर. हो.
So start from A, stop where a circle touches. That distance is S. So AF1 is S, out of which AB is small c. AB is small c. So from S you remove small c. What is remaining?
From AB, if we remove small c, F1, right?
BF1 will be S minus C.
Okay.
From S remove C. But we have said BF1 is equal to BD1, length of tangent.
Yes, sir. I understood. Thank you.
Yes. Okay. So let us go back to the big diagram and complete the remaining distances or okay. Now, just let me do it two times, opposite to B and opposite to C. I2 in place, then what we are going to do is BC plus CA plus AB is perimeter. Perimeter P is equal to BC plus CA plus AB. Okay, if you consider second circle, what are the lengths of tangents? Can you tell me? What are the lengths of tangents? If we consider vertex A, then AE2 is equal to AF2. AE2 is equal to AF2. If you consider B, BF2 is equal to BD2. And if you consider C, it is CD2 equals C2. These are equal distances. Then we start our work with perimeter. BC plus CA plus AB is perimeter. You break CA into parts, BC plus CE2 plus E2A plus E2. CE2 is equal to CD2. C2 plus CD2 म्हणजे आणि E2 ला AF F2 BP plus CD2 is BD2 and F2A plus AB is BF. It's equal to 2 times BD2 equal to 2 times BF is equal to 2S. Therefore, S is equal to BD2 equals BF2, out of which BD2, if you remove BC, which is small a, you get CD2 is equal to S minus A. CD2 is equal to CE2. And out of BF2, if you remove small c, AF2 is S minus B. And AF2 is equal to A. So now we have completed two vertices as far as the circle is concerned, and every time we got 6 distances in terms of S minus B or S minus. In case of in circle also, we got 6 distances. S minus B, S minus. So there will be total 24 distances in this center X center configuration. 6 of them will be type X, 6 of them will be of type S minus A, 6 of them will be of the type S minus B, and 6 S minus. Total 24 is. So in this configuration, everything is known now. All the distances. So if A, B, C are known to us, small a, small b, small c, sides, lengths of sides are known to us, we can find out any distance in this diagram. Sorry. तर आता तुम्ही पहिलं काम काय करा, मी जरा पाणी पिऊन घेतो, खूपच गरमी होती. तुम्ही पहिलं काम काय करा की असाच अजून एक सेट तयार करा opposite to C. So that will help you to understand what we have done. Because for this X circle, I have not done anything on the board. You do it.
हो गया.
Sir, in the last line, you have written S minus B is equal to A F2. It will be S minus B or S minus C? Excuse me, sir.
Yes,
Sir, I just want to ask, that is, in the last line you have written S minus B is equal to AF2 minus AE2.
no, it is not minus. AF2 is equal to
Sorry, equals to, yeah, sir. Yes, AE2. So it will be S minus B or S minus C, sir?
S minus B.
Uh,
S minus C. Yes.
yes, yes,
Sorry. S minus C.
okay.
It is opposite to C. Yes, correct. Correct. Mistake. झालं असेल तर आपण टेबल बनवूया. This is present at 6 places. S minus A is present at 6 places. S minus B is present at 6 places. And S minus C is present at 6 places. If we start with A, AE1, AF1, BD2, BF2, CD3, CE3. These are the 6 positions where you have S. S minus A. AE, AF. CD2, C, D2, B, D3. BD3, BF3. CD2 is CD2. S minus A is present, 6 places. S minus B. C1, A, S minus B. AF3. A is 3, AF3. S minus B. B, D, BF because of inside. So C, C, D2, CE2, CD2, S minus K, S minus B करते हो. CE1, CD1. And S minus C, starting from A, AE2, AF2, Starting from B, GD1, BF1. E, CD. नाही आता जे 4 ठिकाणी आपण काम केलं ना ते एकत्र केलं. मग तुम्ही अपोजिट टू सी चं काम केलं का सांगून गेलो होते मग तुम्हाला 6 नवीन रेशो मिळाले असतात. ते 6 आणि मी आधी काढलेले टोटल 7 12 काढले असे 24. Actually, in next 15 minutes, all those who are present in class, I can make sure that you remember all these distances. करतो बरं का 8वीच्या मुलांना फक्त डायग्राम समोर ठेवायचा आणि I ask you distance BD1 I should say S minus C BF1 S minus C BF3 is S minus A CE2 is S minus A CD1 is S minus B like that you should be able to say. I mean eventually it is required in 11th when you are dealing with trigonometry and it is always good to remember the distances. Therefore, while drawing the diagram, I was aware which distances are going to be equal. Accordingly, I put those perpendiculars so that in the diagram they look alike. तर तुम्हाला हवं असेल तर मी सांगतो कसं लक्षात ठेवायचं ते. Otherwise, you can take your time. The most difficult is when that D1, E2 and F3, these are the points, D1 and D1, so CD1 suddenly you will not realize how much it is. But outside segments, CE1, now first line is very easy. First line is very easy and you will be given this diagram. And of course you should be able to produce it, but it is always given. So S is very easy to remember. If you start from A, wherever you get opposite X circle and stop, that is the longest distance in this, which is S. So AF1, AE1, BD2, BF2, CE3, CD3. That is your first line. So if you remember S, it is going to be useful for finding out remaining ones. So now AE1 is S. And AC is small b, therefore CE1 is S minus B. AE1 is S and AC is small b, therefore CE1 is S minus B. So like that all external distances, exterior distances can be found out quickly. For example, we want to find out CD2, then it is on line BC, therefore S minus A. Suppose we want to find out AF2. Okay, this is C, so S minus C. BF1, S minus C. BD3, S minus E. Easy. Second step is easy. Because S is easy, the exterior segments are also easy. And the most difficult, okay, how do you get how much is AF1? Sorry, AF. F is DEF are the points where you touch in circle. correct? So if you are starting from a vertex and if you happen to touch in circle, then S minus that vertex is that distance. So AF is S minus A, BF is S minus B because we are starting from B. BD is S minus B, CD is S minus C, CE is S minus C. So if it is in circle, from the vertex you are starting S minus that vertex. Of course, we will not write capital C, we will write small c. That is what is the distance as far as in circle is concerned. So third step is to remember distances related to in circle. Start from A, stop at F, where in circle touches S minus A. Start from A, stop at E, where in circle touches S minus A. Easy. Now, if you start from A and stop at F3, that is little difficult. Of course, we can imagine AF3 outside AE3 and calculate, but I remember it like this. F3, D1 and E2 are related to X segments. They are put up perpendicular from X segment. So if you start from A and you are going towards B, and if you happen to touch X circle, then vertex towards which you are going should be subtracted from S. So AF3 is S minus B, PD1 is S minus C, CD1 is S minus B, CE2 is S minus A, AE2 is S minus C. That is how it is. I mean, instantaneously you will get it. Huh? नाही पण यू आर डुईंग गुड आय मीन 7th लेक्चर आता किती अटेंडन्स माझ्याकडे इथे 42 45 45 48 49 50 अरे 54 सर्वाइव्ड आफ्टर 7 लेक्चर्स व्हेरी गुड व्हेरी गुड आतापर्यंत एवढं झालेलं नाही शाबासकी सगळ्यांना हा तर तुम्ही काय करा एवढे दिवस थांबलाच आहे ना तुम्ही So you start shouting on the group. 200 जण आहेत तिथे त्यांना कळू दे जरा जास्त लेक्चर्स अटेंड केल्यामुळे काय फायदा होतो आम्हाला स्टार्ट रायटिंग समथिंग अरे वी हॅव लर्न इन सेंटर एक्स सेंटर टुडे जनरल म्हणजे काय झालं तिकडून जर आले चांगले ना आपल्याला अजून रेकॉर्डिंग बघून समजा काही जण आले परीक्षेला की अरे एवढी धमाल झाली तर आपण पण आता करूया जरा मिस झाले थोडे ग्रुपवर तुम्ही ऑफकोर्स रिलेटेड टू इट whatever we are learning only, but काही लोकांना असतं की थोडं पुश टच करायला
त्या अंडरस्टँडिंग साठी शिकतोय का मुलांना पण हे एक्सपेक्टेड आहे
सगळं मुलांना हे लागतं पुढे
आपण सब्जेक्ट त्याच्यामुळे दे शुड नो ऑन दिस
हो कारण त्यांना हे जर आता शिकवलं तर दे आर मास्टर ऑफ दिस इन 11th and 12th त्यांना ही सगळी डिस्टन्सेस फटाफट येतात आणि हे जर 11th ला शिकवत बसलो आम्ही तर एक तर वेळ जास्त लागतो आणि रेजिस्टन्स पण असतो ऍब्सॉर्ब करायचा आहे सगळं आणि आता काय दिस इज वन कॉन्फिगरेशन वी आर डिस्कसिंग राईट वी कॅन चेंज अवर पॉइंट ऑफ व्ह्यू अँड इट इज अनदर कॉन्फिगरेशन डायग्राम इज सेम बट इट इज ऑल टुगेदर अ डिफरंट कॉन्फिगरेशन तर त्याच्या प्रॉपर्टीज वेगळ्या आहेत अँड if you have this overall view about what is happening under me, then few problems you can solve instantaneously. Very difficult problems. And this is for something की कसं आहे शाळेमध्ये सगळी आपल्या डोक्यातली चक्र फिरत असतात नॅचरली फिरत असतात ती थांबवलेली असतात हे सगळं केल्यामुळे ती चक्र फिरायला लागतात दे विल स्टार्ट आस्किंग क्वेश्चन कॅन आय डू दिस म्हणजे एका तर मुलाने काहीतरी 100 एरियाचे फॉर्म्युले काढून दिले त्या हे सगळं वापरून वी आर डीलिंग विथ 7 or 8 फॉर्म्युले राईट नाव बट तिकडून इकडे मग ट्रिग्नोमेट्रिक मधनं काही फॉर्म्युले येतात त्याचं ह्याच्याबरोबर he has produced a booklet in which he has got more than 100 formulae for area of triangle ABC. मुलं थांबत नाही एकदा त्यांना कळायला लागलं काय चाललंय ते सुरू होतं म्हणून हे शिकवायचं आणि हे म्हणजे परीक्षेत उपयोग होतोय नाही होतोय कुठे काय माहित नाही, पण हेरॉन्स फॉर्म्युले मधले या ज्या आयडेंटिटीज आहेत त्या जॉमेट्रिकली तिथे प्रेझेंट आहेत त्याच ट्रँगलला. And there is no restriction on triangle, how you should draw it. The moment your triangle is fixed, everything is fixed. Concurrency of angle bisector असणार, altitude असणार, median असणार, सगळं असणार. You are free to draw triangle ABC the way you want, and then everything is available. That is the problem. I mean, we started with single thing and it expanded like anything. सगळं लॉजिकल डेव्हलपमेंट आहे, कुठेही शॉर्टकट मारलेलं नाही. फक्त ते टँजेंट ऑफ टू द सर्कलचं मी जरा ते इनडायरेक्ट प्रूफ असल्यामुळे तेवढं घेतलेलं आहे, बस. बाकी सगळं सिस्टमॅटिक. ओके, सो लेट अस प्रॅक्टिस दिस. It will take a little more time, but it is fine. Let me make that in center qualification little big. And keep it in front of you and let me hide the table. नॉर्मली एकेका मुलाला एक लेंथ विचारतो, तर तुम्हाला 4 गोष्टी लक्षात ठेवायच्या. त्या समजण्यात काय, हॅव यू अंडरस्टूड हाऊ टू रिमेंबर दिस 24 distances by remembering 4 tricks. First trick is distance S, which is very easy, the largest in this configuration. Then second trick is you subtract opposite side and get all the external distances. Second step. Third step, you start from vertex A, start from the vertex, and wherever you touch in circle, stop at that point. Then distance traveled is S minus that vertex. And step number 4, start from A towards B. You happen to touch X circle, that distance is S minus B. Towards which vertex you are moving? From A to B, you happen to touch F3, A3 is S minus B. Like that. ठीक आहे. आय मीन पाहिजे असेल तर मी विचारतो, पण तुम्ही अनकम्फर्टेबल असाल तर मला काय नाही विचारत, काय प्रॉब्लेम. विचारू सर, विचारू स्टार्ट करू तुमच्यापासून. डिस्टन्स सांगा, BF किती? नको दिसत नाही सर. BF -8 नाही. आता टोटल 4
S minus B. S minus B.
BF
S minus
is S minus B. Starting from B and touching in circle. S minus.
S minus B.
BD1. B दाखवतो.
minus
D1. अरे आज तुम्हाला पण सगळ्यांना विचारतो, थांबा बोला. BD1.
S minus C.
तुम्ही बोलू नका, तुम्हाला विचारतो. तुम्हाला विचारल्यावर नाही येणार आहे, दुसऱ्याला विचारलेलं असतं नाही येतं आपल्याला. बरं, किती काय सांगितलं? S minus C. करेक्ट. हा मॅडम, CE2. हा बघा, CE2.
S minus A.
करेक्ट. AE3. Sorry, AE1. AE1. Here is AE1. Yes. सांगितलं? Yes, longest. हा तुम्ही मॅडम. AE3. सांगताय? AE3. A distance. S minus B. बरोबर. म्हणजे AE3 म्हणजे AE3 म्हणजे हो, AF नाही. AE3 म्हणजे AF3. बरोबर. हा सर. CD1. S minus B. Correct. Mark. BF1. Correct. A E2.
S minus A.
9. A E2. E2 is X circle. Starting from A, stopping at E2. X circle. So S minus C. Sir, to me. A F2.
S minus C.
To me. A E. Correct. Last. B D. S minus B. S minus B. कोणाला इंटरेस्ट आहे विचारू ऑनलाइन ज्यांचे व्हिडिओ आहेत तेवढ्यांना विचारू नाव दिसायला हवी फक्त अर्पिता मॅडम BD3
BD3. Sir, S minus C.
नाही
S minus A.
रश्मी मॅडम BD1
BD1.
S minus C.
करेक्ट प्रीती मॅडम A2
S minus C.
करेक्ट कोटेश्वर सर CD1
Sir, I'm lost.
CD1
CD1
S minus B.
is opposite.
तर पडायचं नाही ए सर CD1
I'm guessing, sir, S minus B.
करेक्ट
Okay.
नेक्स्ट अदिती मॅडम BD
So take a second. BD. It must be S minus C.
नाही
But sir, we are heading towards C. Right?
but it is in circle ना
इन सेंटर एक्स सर्कल की आइडिया सांग इन सेंटर ला एस माइनस
First, S minus B. BD is S minus B. From where you have started? Rajeshri madam, followed by Shubhangi madam.
Sir, एकच doubt होता. For in circle, we have to deduct किंवा subtract the point to where we are heading.
नहीं,
And for
from where you have started for in circle.
X circle and for in circle.
ऐका, for in circle, from where you have started, you should subtract. For X circle, for which vertex you are going, you should subtract.
Okay.
Rajeshri madam, AF1.
S.
Correct. Then Shubhangi madam, A2.
S minus A.
C.
Not correct. A2. Towards which vertex you are moving?
S minus C. S minus C.
Correct. Anup sir. CE.
CE is going towards A, and sorry, it is the in center. So C S minus C.
Correct. Guru madam. CD1.
S minus B.
Correct. Very good. Sachin sir. BD. Mic is off.
S minus B.
Correct. Pragati madam. AE3.
AE3. Okay, sir. S minus B.
Very good.
Thank you, sir.
Then ज्योत्स्ना मॅडम आहेत का? नाहीतर गंधरेखा मॅडम. AF3.
AF3. S minus B.
Correct. Very good. Madhura madam. AE2.
So can you repeat?
AE2.
S minus C.
Correct. Then Vrushali madam. CE1.
CE1. S minus B.
Very good. Then दापके पुढे अच्छा दिसत नाही, जाऊ द्या. दीक्षा मॅडम. दीक्षा. CT.
S minus C, sir.
Correct. Sumedha madam. AF2. बाकीचे व्हिडिओ बंद करून बसले, नको विचारायला.
सो ते बॅक साइडला जाताना उलट ते नाही कळत आहे मला. जे आता AF3 असेल तर दॅट विल बी S minus B.
आता AF2 पाहिजे. AF2. तर
ते
पहिलं सांगा BF2 किती?
BF2 is S minus A ना.
नाही BF2. BF2. नीट विचार करून सांगा. BF2 किती? BF2 लांब आहे ना खूप.
BF2 म्हणजे S.
S. आणि मग BA किती?
BA is C.
म्हणून AF2 किती?
2 is S minus C.
Correct. Very good. Done. Sir. Yes.
DD1 असं
करते नाही. तेच करणार आहे. तेच करतोय. Now can we find out DD1? Or before that, D2, D3. Find D2, D3. D2, D3. सगळे तर माहिती आहे तुम्हाला, त्याचे किती पाहिजे तेवढे तुकडे करा आणि मोजा. D2, D3 पाहिजे. BD2 माहिती आहे. Yes, आणि BD3 पण माहिती आहे. So D2, D3 is equal to BD2 plus BD3. बरोबर? BD2 is S and BD3 is S minus A. बरोबर? So 2S minus A. त्याला जरा सिम्प्लिफाय करू शकतो आपण. 2S is A plus B plus C. Therefore 2S minus A is B plus C. So if you press this A, press such that from A to D, A coincides D, then that triangle will become flat. And how much is DD3? Find out. DD3. Find out DD3. BD is S minus B and BD3 is S minus A. S minus B plus S minus A. 2S minus B minus A. You see, BD3 is BD plus BD3 is DD3. BD is S minus B plus BD3 is S minus A. So 2S minus A minus B is small c. So small c is AB and small c is DD3. That is why I was saying if you trace from A in the direction of D, when they are collinear, DD3 is C. So असा हा फ्लॅट उडत चालला असा A. इथे इंच असेल. And therefore DD2 is B. DD2 is small b. आणि हे समजा A प्रेस केल्यामुळे होत असेल तर मी B प्रेस करून पण राहणार, C प्रेस करून पण राहणार. आता DD1 काढा, DD1 this distance. D2 D3 is B plus C, DD1 is C minus B, bigger minus small. BD1 minus BD. BD1 is S minus C minus S minus B. Which will be B minus C. Symmetry किती आहे बघा. DD2 is B plus C, DD1 is B minus C. Now this has applications. I mean, when you learn constructing triangles, there is one specific construction where unless you don't know these distances, you cannot solve that construction. So I mean this is interesting. So if without calculating, if DD2 D3 is B plus C vertices, those two vertices which are on that segment, then E1 E3 is A plus C. And F1 F2 is A plus B. FF3 is A minus B. E2 is C minus A or A minus C, whichever is bigger. C minus A or A minus C, whichever is bigger. So you know these small distances, you know these big distances, everything is known. The moment you draw triangle ABC, everything about that triangle is known. इक्विलेटर असेल तर थोडा अवघड असतं की बऱ्याचशा गोष्टी सेम असणार. ही डायग्राम सुद्धा काढणं अवघड असतं. Because F and F3 will coincide. F3 will coincide. D कारण इथे B minus C होता, तो 0 झाला. DD1 will become 0 if it is equilateral because DD1 is B minus C. त्यामुळे ऍक्च्युअली आता मी सुद्धा काढताना भरपूर काळजी घेऊन सुद्धा हा आयसोसेलेस झालाय असा. पण आता ठीक आहे, थोडा एक्सपिरियन्स असल्यामुळे मी ते फुट ऑफ परपेंडिक्युलर बाजूला करून घेतले मला पाहिजे तसे. पण इट इज डिफिकल्ट टू कन्स्ट्रक्ट स्केलिंग ट्रायंगल, not equilateral, not isosceles. So I will supply you with a good figure.
Sir, excuse me. Can you please move the board a little bit up?
Oh, okay. काही काही प्रूफ्स येतात पायथागोरसचं प्रूफ पडतं याच्यात 2-3 प्रूफ आहेत पायथागोरसची बिकॉज वी नो दिस डिस्टन्स. Okay, so this is in center, X center configuration. I think we should stop. जरा जास्त झाले आता. आणि करताय पण If you have any question, next lecture, that is Thursday, we will solve few problems in class based on whatever is discussed theory so far. What kind of questions can we construct? So I will give you demonstration of the questions, maybe difficult questions, to be solved using these fundamental ideas that we have learned in last 7 lectures. That is what we will do. Exam will be offline. 10 ते 12 वाटतं.
पण टेस्ट एक्झाम किती तारखेला आहे?
Exam 20 April. MIT College. Details will be sent up through.
आणि
Sir, we were
एक्झामचं
told
म्हणजे स्वरूप
18th April.
काय म्हणताय?
Sorry, sir, in the communication it was shared 18th April.
नाही 20th.
20th. Okay.
आणि पॅटर्न कसा असणार एक्झामचा? हाऊ मेनी क्वेश्चन्स किंवा व्हॉट काइंड ऑफ सॉरी
बघू अजून ठरवलं नाही.
अच्छा
ऑनलाईन स्टुडंट्स करतात.
ऑनलाईन साठी आहे का?
ऑनलाईन साठी प्रॉक्टर्ड एक्झाम आहे. We will conduct proctored exam. I mean, there is a method which will be sent on group. You should follow that method and send us the answer. बघू
Sir,
मुलांसाठी काय तुमच्यासाठी काय करायचं मध्ये जरा गॅप आहे मी विचार करतो.
अच्छा सर आणि
Sir,
आधीचे लेक्चरचे रेकॉर्डिंग मिळू शकेल का? पहिल्या
रेकॉर्डिंग सगळ्या ग्रुप वरती आहे ऑलरेडी. सगळ्या लेक्चरचं रेकॉर्डिंग आहे.
अच्छा ओके.
तर ही जी बिग डायग्राम आहे ना कॉन्फिगरेशन वाली ती PDF मध्ये पाठवाल का ग्रुपवर?
हो पाठवणार. याच्यावर जर मला प्रश्न विचारायचा असेल तर ती डायग्राम एक्झाम मध्ये पण देणार.
ओके.
सर ऑनलाईन स्टुडंट्स ऑफलाईन येऊ शकतात एक्झाम साठी?
वा म्हणजे आम्ही सत्कारच करू. श्रीफळ आणि शाल.
सर टायमिंग असेल ना? हॅलो सर.
टायमिंग 10 ते 12.
हा मग ठीक आहे चालेल. ओके
चालेल. ओके थँक्यू. भरपूर अभ्यास करा.
थँक्यू सर.